Hello girls and guys, and welcome to this video. In this video we're going to talk about the linear regression with multiple variables. In the previous videos we had talked about the linear regression with one variable, also known as univariate linear regression. Now from this video I would like to start talking about the linear regression with multiple variables, also known as multivariate linear regression. So first of all, let's take a look at some of the notations that we will see in our equations for linear equation with multiple variable. Now first of all, let me show you what the multiple variable looks like. Here, in an example of linear regression with one variable, we only have two features. But in case of linear regression with multiple variable or a multivariate linear regression, we have multiple features. Features are just like the that I'm highlighting it, or they are called the variables. They are called the variables, and here x is this one, x1, x2, x3, and x4. And you might be thinking, Ayush, why don't we choose this as x, because it is also our variable or feature. So listen, that we are not choosing this because what we have to do, we have to predict the price of the particular whatever it can be on the basis of all our input. The input are x1, x2, x3 and x4, and on the basis of these x's we have to predict the price, which is y, and this is also called the target variable, known as a target variable. So I'm recapitulating that they are called the features or a variables or input variable or input features. So let me write this thing here so that you can get the notes clearly. So they are called the input variables. You can think of it as input variables or features, etc. You can think of it as they are called input variables, and we have, this is the target variable, target variables, and this is called the y, which we have to predict on the basis of our input variables. Okay, now let's take a look at some of the notations that we are getting to know in this equations further. The first equation is n. You know that m equals to the number of training examples. Is the number of training examples. We have taken out in the implementation that m equals to the length of y. Okay, here y is the m, is the number of training examples. Just think about it. Now here n is the number of features that we have. Here n is the number of features that we have, and then we have x superscript I. And you might be thinking that, Ayush, first tell what is n is the number of features that they are called the features. Number of bedrooms, number of floors, age of a home, and this is our target variable. So here n is the number of features. Now what is xi here? Xi is the input features of I training examples. It is telling input feature, and input feature are this from here, and just name it as x1, x2, x3, x4. Okay, now they are called the input features, and we are saying that input features of I training example. We have to take all these features and what the input should be. So it is saying that, let's take an example. We have x, and let's take this is x1, x2, x3, x4, and let's take x2 here. X2, let's see, and we have here 1, 2, 3, 4. And what's telling is that input features of all the features of I training example. Here I is 2, and we can think of it as I this by stacking them in a vector 1, 4, 1, 6. Then we have 3 here, then we have 2 here, then we have 40 here. Now this is our input feature or xi. Okay, because you can also take x3 here. We're going to stacking them all up, and we're going to 1, 5, 3, 4, 3 to 30. Okay, now this is all about our xi. Now let's take a look at xj, x superscript I and subscript j. Here j is the feature. Here j is our feature, and here I is our ith training example, okay, that I have written here. Now let's take a look of example and you will get familiar with that. Let's take that here we have again x1, x2, x3, x4, and we have again 1, 2, 3, 4. Okay, now let's take a look at x subscript 2. It means j should be a 2. So here the 2 here is the number of bedrooms. We have the feature which is the number of bedrooms because j is the feature. Okay, now second example means I training example. For second we have 3 because 1, 2, so we have 3. Okay, now I think that you got familiar with n, x superscript I, x superscript I, subscript j. These are some of the very important notation that you should familiar with that. Okay, now let's take a look at the general hypothesis form for a multivariate linear regression. We've studied that univariate hypothesis function have a something like this, that h of x equals to theta 0 plus theta 1 times x. It is for linear regression with 2 variables, okay, or 1 variable. Now here, one variable. So what we are doing is that we are just theta 0 plus theta 1 times x because we are giving only one input. But when we talk about the many input, so for that we have multivariate hypothesis function, and that the general form for our hypothesis will look something like that, because we have the multiple inputs, and based on multiple inputs we have to predict. Let's take an example of house that we have seen in our just an example, that on the basis of the number of bedrooms, number of floors, etc., on the basis of that we have to predict the price of the house. Okay, now I think that you got what the thing that I'm going to say here. Okay, now let's explore more about our hypothesis function. So first of all, we have something like this form of our hypothesis function, and on the basis of our input, which is our x here, we have to predict y. So first of all, let's stack this x into this. Now x0, x1, x2, x3 till xn, and let's do this theta 0, theta 1, theta 2 till theta n. And what we can do is that we can transpose our theta times our x. So theta, when we write theta transpose, when we do the transposition of our theta, let's make it so better. Here x we have equals to x0, x1 until xn, and then we have our theta equals to theta 0, theta 1 till theta n. Now if we transpose our theta, so what we are going to get? If we transpose our theta, we're going to get stacking them up in a horizontal direction. So we are going to get a theta 0, theta 1, theta till theta n times our x0, x1 till n. Okay, the general formula for this, and this all is the theta transpose, and we can get say that our theta transpose x. So we got a very good formula for this, theta transpose x. Now we can conclude that h of x equals to whatever our theta is, so we have till theta 0, theta 1 till theta n, and what we are doing, we are multiplying it by a specific x0 till xn, which is our input, and what we're going to get, we are going to theta transpose. I have talk about the transposition and inverse of a matrix in my mathematics for machine learning. In case you don't know, please be sure to check it out. I will give a link in the description box below. Okay, now here what I have done, we have done a simply theta transpose x. Okay, the notes will be provided in a beautiful form. I will rewrite all those things and explaining you step by step because I've erased all of that. So be sure to check it out, the notes in the description box below. And that's it for this video. So I think that you got a better intuition behind our hypothesis function. Okay, now if you are new to the channel, be sure to subscribe this YouTube channel, press the notification bell, and share this video so that I can get a benefit from my channel. Recall, sharing is caring. Now, thank you for seeing this video. Till then, bye bye.